Hey, good morning. It's that time again, Patch Tuesday. How many of you are kind of anxious about that day? I know probably not a lot of CISOs here in the room, but a lot of my clients and a lot of companies around the world are kind of waiting anxiously to that day to discover dozens and hundreds of new important and critical vulnerabilities. And kind of the expectation is that those security updates that are introduced to the public during Patch Tuesday, and it's the same for other vendors as well, are a complete fix, kind of a Fort Knox security update to recently discovered vulnerabilities. Frequently, this is what you get. Now, it's not the vendor fault, and there was a great keynote speaking. There's a lot of urgency, a lot of discovered reporting, and a very short disclosure policy. So those vulnerabilities definitely need to be somehow patched. And many times those frequently discovered vulnerabilities take a while, a couple of security update cycles, until all the possible control flows will be patched. The point of this presentation is how we are finding new vulnerabilities by observing the different security updates that were introduced to the world. So me wearing both hats, both as a leader of a company and vendor, kind of worry about the updates, but also as a vulnerability researcher, I'm extremely excited about that day, reviewing those security updates to come. So first about myself, my name is Michael Gorelik. I'm the Chief Technology Officer and founder of Morphisec, a endpoint security company. I had the privilege to present in a number of conferences. This presentation is actually an extension of my DEF CON presentation with a couple of more vulnerabilities and more insights. I had the opportunity to discover one of the largest supply chain attacks, the CCleaner, and to report it to Avast at some time. And had more than 20 years of security experience catching those bad guys and helping the authorities with their efforts. Though not together with me, but Arnold Osipov is a great contributor to this presentation. We presented together at the DEF CON, so it's kudos to him. I had to mention him here as well. We have a lot to cover, quite a significant amount of vulnerabilities. 5 remote code execution vulnerabilities in a very short time. We will focus on 2 categories of vulnerabilities. The first category will require authentication, prior authentication. We are talking here about form injection vulnerabilities. So assuming I have an access to your inbox, my goal is to run malicious code on your environment, basically inject a malicious form. So we'll talk about that. There will be the first discovered remote code execution by the NetSpy group this year. And then as part of our review of the security updates, we discovered every month additional vulnerability that will be described here. The second category of vulnerabilities will be monocure type of vulnerabilities that eventually lead to remote code execution. Was discovered by Haifei Li from Checkpoint. And then as part of our review of security updates, we discovered additional remote code executions. So let's start with the first category, form injection. So everything, more or less all type of messages in Outlook are forms. Now many people kind of consider forms those kind of grayish input boxes and some buttons, but it's much more significant than that. It has functionality behind it. When you get a reminder, someone needs to do the beep, and there are more complex forms, such as, for example, recall messages that are being sent and need to remove the emails from your boss email just before he reads that email. Our goal is obviously to create such a malicious form and being able to inject it into the victim environment. And I remind you, authentication is required here. Okay, so first, what is outside of the scope? I have to mention E.T.S. Stevens done a great presentation about forms, Visual Basic within forms, and rules injection. This is outside of the scope, but you are welcome to check out a lot of YouTube links, and he was one of the first ones to talk about form injections and created the ruler, which is really a great tool to to help us demonstrate POCs on forms. So we are going to create custom forms. And as I already mentioned, many of the messages are based on forms, whether those are calendar invites, just email messages, appointments, anything else that you would get through Outlook. So how do we create a custom form? So there are two main ways to create a custom forms. Our goal, I remind you, to create a malicious form. One way to create custom form, just use this advanced ribbon, edit, and you have a developer tab. And then you can basically extend the built-in Microsoft Forms, whether it's a calendar invite or a message, add some buttons, add some nice sound. You can do that. And as a result, you will have a new type of form, which you can publish to your folder. We are more interested in programmatic way to create forms. And this is using basically configuration file called CFG. The same file has all the properties that you will expect from a form and some more. This is taken from a Microsoft documentation. In this case, you have what is interesting here is the registry field that also points to a form server, essentially a COM object that can execute and render form and provide more functionality. We'll talk about that. It would be great, obviously, to create something like that on the victim machine. I'll not get into, because of lack of time, into much details about the protocol, how forms are synchronized, but our goal is to inject malicious form and trigger it. It has a couple of steps. First, obviously, creating a form, then implanting that form into the malicious victim, and then triggering the execution of that form. Those are different steps. The implant of the forms is allowed through Microsoft protocol, synchronization protocols. You basically can create your own form, and Microsoft will sync it for you into the victim environment. A simple example is your draft emails that you create in your inbox, and this is propagated through the exchange on all your Outlook clients. You see that suddenly everywhere. The same can be done with your forms and custom forms. They are also synchronized, and we will use that basically to implant that form into your environment. Now, it's important to know that if you are putting that form into special folders, multi-folders like inbox, they will be propagated, but if you install those into your personal folders, they will stay within the scope of your endpoint. Couple of basic things. There was a great discussion by James on COM. I will not get into too much details after this interesting discussion, but this is an example of you creating a custom form from a built-in Microsoft form using interactive way. As a result, a COM object representing that form will be generated and registered within the class ID within your registry. If you have a Outlook 32-bit, it will be under WOW 64 within the class ID. If it's 64-bit, it will be directly under the class ID. Essentially, this class ID will have the message name of the form to be able to identify it and recognize. It will have a couple of properties like the form stager, which will point to the location of the form that you just generated, to the OLE that was just generated. And usually you can find them within the roaming folder, Microsoft Forms application, kind of a TMP file that you can then reverse, and it's extremely interesting. Now, Microsoft synchronizes and put those forms within that folder. Now, this is important because we'll mention it forward, how this can be also manipulated. One more example of a built-in form that each one of you have if you are installed an Outlook client. You can check out the built-in folder for Microsoft Office number something 1033. You can find it in your program files. You'll see a recall form. I'll just mention it at the start. It's a built-in form, message Outlook recall, with its own CFG file. This is a CFG file you guys can find. Now, recall functionality today, you can do that within the cloud without executing this endpoint protocol. But if the cloud recall is turned off, then you are folding back to the original recall. What happens really is that this recall.dll, which is also located within the built-in folder and pointed by the registry, will be executed, basically instantiated by the COM.get class object. And this will essentially go over the inbox and will start to delete the message that you send with your recall. It's a great example. Would be nice and great if we could create a very similar type of example, synchronize our recall DLL to wherever we want, to the form folder, and then execute it by sending a special message within the email, right? We don't need even to send the DLL itself. To prevent that from happening so that not anyone can register any form they like, Microsoft has an interesting deny list functionality. If it's not marked, if it's not turned on, you have by default a deny list which validates that within your form, your CFG form, the registry property doesn't point to this set of properties, keys. You probably identify those keys that can be instantiated by the COM loading operations. In a way, you can basically hijack path value, COM hijack, and then execute your own stuff. We saw that in the example with the recall, which they had in proc server 32 pointing to a DLL, while local server points to an executable. It depends whether you want to execute it within the Outlook executable or outside Outlook executable. So one more thing is the NetSpy, obviously, the first vulnerability. This is not discovered by us, but they've done a great job showing it. One of the challenges with the deny list matching is that the deny lists were validating an exact matching to an exact name of those of this list that I showed before. If you have it within the registry in proc server 32, it will be blocked and an error will be received and the form will not be registered. But if you add some characters, anything, to that registry key, it will bypass the deny list. So how do you create a still valid flow, adding something into that registry key and executing while bypassing the deny list? So the NetSpy group discovered that you can use a relative path with the class ID. You still have the same functionality because it's still written as a class ID within your class ID. And the inproc server 32 will be created by reg createx, and eventually the evil DLL will be instantiated by the COM. Now we are kind of starting the presentation, right? One more thing, though we'll not be talking about, they also discovered that you can synchronize your form not only within the form directory, but in other directories as well, but it's less interesting for us for this presentation. So how Microsoft patched that vulnerability? Basically, the first security patch Tuesday introduced the fix to this vulnerability. And the fix wasn't trying to make it, let's say, a more interesting validation that contains those keywords, but to remove the relative path. I will mention again one more thing that I didn't mention before. One more reason, because of the urgency, aside of the urgency for vendors not to introduce complete fixes, is also not disrupting applications. Many of those modules are loaded and used by other applications as well. Neither Microsoft nor anyone else want to kill applications, disrupt applications, and this is why security updates many times introduced kind of sequentially in a growing manner. So Microsoft removed the option to load the relative path. The documentation is still there, unfortunately, but you cannot create a form with a relative path for registration. So now we discovered our next vulnerability. How can we still add interesting characters to bypass that deny list, but let the registry instantiate? To understand that, we first need to identify that registry manipulation functions, the core functions like registry create X, but also other registry manipulation functions, you can send them a key that composed with many keys by basically separating them with backslash. I think the maximum is around 32 keywords at one go. But one more important property is that if you provided a backslash at the end, it will be disregarded for consistency, obviously. And the registry creation will work just without the backslash. So you probably guess correctly. We added a backslash, right? So the backslash worked. The exact matching failed. The inproc server 32 wasn't found. But the registry create_x created that key successfully, and we had a form server execution within the context of the Outlook process. So every time you are sent a special message with our message class that we want, this will be automatically executed. Okay, so at this stage, what was the fix? What was the next security update in the next patch Tuesday? So the next security update was still not fixing necessarily the exact deny matching. It was introducing, before we are doing the matching, let's remove all the backslashes, the trailing backslashes. In this way, hopefully we'll be okay with an exact matching. And this worked. This worked for those new COM forms that are executed. As I mentioned before, one of the things we do, we are reviewing the security updates for additional interesting stuff that was introduced as part of them. During that security update, when they fixed the previous vulnerability, they enhanced the deny list with additional names. Now, for some of you, that may be reminding something. COM hijacks, you can check out different presentations, especially Casey Smith and Matt Nelson, but also other important people were talking about how to hijack COM, not only by key value, but also existing COMs by introducing special keywords. In our case, some of those keywords, for example, treat_s allows delegation to other COM objects. So it kind of raised the question, are there additional keywords that are not blacklisted in this deny list that we can use? So this created the third remote code execution. We are still talking about the same vulnerability. We are to hijack an existing COM. We are not creating right now a new form. We are hijacking an existing form. And because you can create any class ID within your CFG file, we can also point to an existing class COM objects. We cherry-picked this COM object that is responsible for the manipulations of this PC. This PC, basically, you right-click, you check out the different files. There are other COM objects as well, but it has an interesting property that if you add this known key property, shell non-command, then you can it will be automatically executed by the get class object with the right context. And instead of calculator, you obviously can do PowerShell and other stuff and make it more malicious. So the point is that we don't want existing class objects to be overridden or keys added to them. So now the fix was finally complete, and I have to comment Microsoft done a great work. They patched it very quickly. We reported the vulnerabilities, and they were patched within 2 months, I think, which is very quick. And this time it was more complete. So first fix was to check out that when you register a new form, it validates if this kind of class object already exists. Now, if it exists and doesn't have the built-in properties that you would expect from a form, which I mentioned at start, message class form stager, then you will have an error and this will not be created. Obviously, if you have already a form with those properties, it will not work. Now, if you create a new form, this validation is less relevant. Additional fix was introducing the contain in the prefix shell as we used as a keyword to execute our calculator or any other command. This time not as part of a deny list, but immediately after as a contain, which is correct because it can come with additional commands, not only shell none, it can come with shell open and other options as well. So this is a good fix. So good reading. We finally finalized our work there and finished with a good enough fix. You can do a lot of things with forms. Now, I just mentioned an injection of malicious form into a victim environment, but it's really dependent on how much privileges you have. If you are an Exchange administrator, you can do much more. You can inject into any of the employees' forms. You can do some persistency. Essentially, Microsoft synchronizes that executables for you into the right forms, and then you can leverage them for other purposes as well. Why I'm talking about NTLM, though this is not the topic of the discussion. I did mention authentication is required. How challenging is it to get authentication today and basically chain that CVEs into a full remote code execution without authentication? It's not very, let's say, it's not very complicated. There were a great discussion by Steve Seifus from BlueHat 2023 about deprecating NTLM. It's not easy. It will probably not be easy for a couple of years forward, even with Kerberos and everything. You still have a fallback mechanisms. Microsoft introduced a lot of hardening options to definitely utilize them, but I'm working with companies all across the globe. There are different applications that still break, and this will take time. What is NTLM essentially? Whether you're sending a link to, or whether it's a social engineering or an exploitation, if the link is clicked or executed, and let's say you have a remote server, a ROC server, it's a challenge response authentication, one way. So I get your NTLM, which says who you are, and basically I can brute force the NTLM. If your passwords are complex enough, I can relay the NTLM. I can use other attacks to utilize NTLM to get my way. And 2023 and 2024 definitely have been the years of NTLM. Exploitations, only we reported around 10 or 12, but those were reduced to medium severity due to the urgency, due to the amount of reports probably. But this is a significant problem. So authentication is not very challenging. You do have ways around it. You can harden your environment, block SMB out. You can enforce Kerberos and other stuff, but still you are in problem. Okay, so let's talk about the second category of vulnerabilities. The second category of vulnerabilities is about monikers. How can we do remote code execution? So Haifa Lee from Checkpoint introduced us to the first remote code execution, though monikers have been there a while, and there are plenty of CVEs around monikers, whether it's NTLM leaks or others. So first we need to understand what are monikers. So very kind of high level. Monikers are there to, as a baseline for the COM or Elite subsystem to connect and identify objects. Basically provide us the interface access to different objects. If you want, especially is used in documents embedding, but in anywhere else, a great example is me sending a chart or an Excel worksheet through the email. Behind that, there's an operation which needs to identify that this is a link to an Excel file moniker and needs to find the right object. If it's a URL, then it will open the browser. If it's an Excel, then it will open the Excel and get you the right results. And everything below as the baseline are those monikers that allows you to manipulate and link those objects. There are different types of built-in OLE monikers. You can define your own, you can create your own, as long as you implement the iMoniker interface. Probably the most popular ones are URL monikers and file monikers. As the name suggests, when you get URLs, HTTPS:// it's translated as eventually, unless there are specific vulnerability, which we will discuss, to a URL moniker. If you have like FTP : or just a absolute path of a file system or relative path to a network file system, it will be parsed and translated to a file moniker. And this is more or less how it works. A great simple example, you're writing your own Visual Basic macro or code, and use the getObject function, which is translated to co-getObject internal, Windows 32 internal, and you put a file :path. In this way, a file moniker will be generated, an interface will be created, and you will be able to access your file within the Visual Basic execution. When implementing a moniker, you do need to implement some of its methods, such as bind to object, which essentially is the method that allows you to bind the string to the right object. So what happens when you are sending, let's say, a remote file as a hyperlink to your email? You would usually expect that there will be some kind of notification. It might be harmful content. Do not access it. Sometimes you get a message such as something went wrong. But what is good is that it is not accessed. If it would be accessed, then again, we are getting back to our NTLM leaks. It's not good. And if it's being parsed, then we can eventually get to remote code execution, which we don't want to. So if you send something like that, today, at least, if you have all your security update, you are good. So what Haifeli found out, at least in his first vulnerability on monikers, he found out if you add an exclamation mark to the end of the link and then something after that, it will be parsed not as an exact file moniker, but as a combination, a composition of monikers, basically a file moniker and then an item moniker. The whole point behind that is that, and a great example is, you probably saw when you have an Excel and you want to address a specific worksheet within the Excel, you use an exclamation mark. You want to access an object within the Excel file system. You want to access a specific worksheet or a range or a cell. And this is why this mechanism is there, so that using the moniker, you can access very quickly to the right object through the interface. But doing so, it kind of jumped over some validation and get immediately to the unsafe function that we will talk about that. And this is why the file was accessed, NTLM was leaked, and even furthermore, a remote code execution was possible, which I will demonstrate soon. Okay, so overall, if you look at Office applications, many times they load this set of MSO type of DLLs libraries. The different libraries are responsible for processing links, images, etc. We are specifically interested in the MSO30 DLL. This MSO30 DLL has the MSO HR HLink create from string function, a very long name, which essentially wrapping the HLink create from string function. This function is responsible basically for processing the hyperlinks. So we're being sent a hyperlink to the email. This function is being executed and tries to parse the string, which represents the file or anything else. And the HLink create from string is responsible to basically convert that to the right monikers. If you would send a file or URL, it will create the right file moniker or URL moniker. Oh, let's just a second. One more thing is, if you look at the documentation of this function, it kind of already provides some hints into what we are going to see. The HLink create from string under specific condition will call make parse display name from OLE32. Now, this function is extremely not safe, and it shouldn't be executed with non-trusted code, and there's even a recommendation for that. There is one more interesting point, that if an input will be provided with an exclamation mark, essentially the prog ID that points to the right moniker object will be instantiated quite automatically. So we have everything we need to generate and cause our Outlook to access the object. Also in the documentation, as I already mentioned, the make parse display name X is not really safe, and it accesses objects during the creation. So as an adversary, my goal is to get to that function. If I can, then the objects will be accessed. When reversing the code of the HLink function, we find out that if the string has one of those characters, now hyphen mentioned exclamation mark, but there are a couple of additional characters. If they are there, basically the file moniker will be disregarded. There will not be a create file moniker function. It will not be called. And instead, the make parse display name will be called to do the work for us, specifically access the item that is pointed by the file moniker. So we need to generate a condition that will have one of those symbols and will disregard the create file moniker. And that's exactly what was done. Now, one more point. So it's obvious why NTLM is leaked, because of access to the object. But when you are accessing the item within that file moniker object, you also parse the file itself. So the file itself could be an Excel or could be a Word file. And during the parsing, what you have is kind of a container that is spawned, like a Word or an Excel. Preview mode is disregarded, no preview mode there, and medium integrity. And the parsing itself can be abused. So if you have an Excel or a Word with a parsing vulnerability, this can cause to remote code execution. Now, this is what I meant by a more complicated, because it requires a chain of CVEs to achieve a full remote code execution. Nevertheless, it's possible. We have enough examples from the past couple of years of vulnerabilities during parsing. Okay, so we are studying about the patches, how Microsoft introduced the first security update to this fix, and what can we learn from that update. So first we need to understand, because some of the files like OLE32 and HLink are used by other applications as well. They are not only Office files. Microsoft uses editors, or basically, in a way, hot patching, call it, to introduce security updates or patches in the case for offices. For example, if we want to fix one of our functions, like make parse that is implemented within the OLE32, then editor function will be used to hook the make parse display only if the call is coming from Office application. So at the top, we have validation on the ID of the application, and each Office application has its own ID. And if it's the right ID, we'll do the detours and we'll hook the make parse to introduce our fixes. So if it's not coming from Office, it's still vulnerable. So this is the example, the real example, what was introduced. The make parse display name and make parse display name X were hooked if it's being called from Office application. And as you see, the detour is being attached, and the MSO is the one that is responsible to do the hooking. MSO is loaded by Office. So what happens within the hook? So we hook them and make parse display name, which is great. How do we fix that? How do we validate that the string is untrusted? So basically, Microsoft said, okay, if within the hook they validate a new flag, they call it get block make parse display name current thread, a very long name for a flag. But as you would expect, if that flag is turned on, return an error. Do not execute make parse name. If this flag is turned off, you can go with the original flow. So the question then, where's this flag set? Who is setting that flag and where? Because we want that to be only relevant for Office application and only for this specific vulnerability. So exactly as you would expect, the flag is turned on when this function, the original function that I showed you before, the MSO HR HLink create from string is executed. Basically, when you have a hyperlink, you double click on that hyperlink, or you have some preview of that hyperlink. This function is called from the MSO. The flag is turned on, and if it gets eventually to the make parse display name, it will return an error because the flag is turned on. Okay. So it was the first fix. This raises questions, right? Is the only path in MSO or in Outlook is coming from that function? Can we bypass it by going through other functions? What about other applications? What about other threats? Because it's only relevant for this thread. There are many more interesting questions and opportunities for us as security researchers to find additional control flows. And this is exactly what we've done. Just to remind you again on the flow of processing a hyperlink moniker, we are starting again from the MSO HR link create from string that gets and processes the hyperlink. It sends the string to the H link create from string, which essentially executes the unsafe function make parse display name. The patch introduced, we have the turn on of the flag within the MSO HR create from string, and the detour validates that this flag is on and returns an error. What about other functions that can go through the same flow? Okay, so we found a function. It wasn't very difficult. Open IDA, check out references. You'll find a quick flow, and there's a new function, hprmon URL, that also executes the same flow and gets to make parse display name. So the question is, how do we make it trigger? How do we make it work? And this was our second remote code execution that we introduced. This remote code execution was patched in July. Again, very quick work by Microsoft. So if you provide a link within an image container or URL container in a way, then this function will be triggered. You can try out, again, multiple execution within the Outlook. In this case, this image source will get to the hprmon from URL. And again, it will execute due to the exclamation mark. It will bypass the validation and will jump to the make parse display name. What is the fix to that? Okay, turning on the flag on that function as well. Okay, so this time this flag is also set on that function. And exactly the same way, it is validated by Microsoft, and we are good to go. We didn't validate additional flows because we were looking into additional new categories. Okay. So it's obvious kind of in the summary that security updates are important. It's important to be up to date. But you have to do additional things to reduce the attack surface. If you can harden your environment more, this is just a bunch of things that you can do. There are much more and beyond. If you can block your outbound to outside, then it's amazing, if you can. Obviously, enforce Kerberos authentication. It will definitely block, at least for moniker execution, not necessarily the form execution. You need to monitor keys creation for the forms. If there are special interesting keys like in Observatory 2 are generated in the registry, then, yeah, go ahead.
You have 5 minutes.
Okay, sorry. No, I'm finishing. Definitely please apply the right hardening into your organization if possible. Finally, the last slide is credits. A lot of works were possible due to the researcher community. They've done amazing work. I have to appreciate what they have done, trying to continue this work and help the industry and make the applications safer. And I think we have a very good cooperation with Microsoft. I really like to work with them, though I found previous vulnerabilities in McAfee and other vendors as well. I like the most working with Microsoft. It's amazing. Thank you.